Hello and welcome back. This, chapter 3, is concerned with our vital statistics. Some statistics really do matter. Every baby that's been born since 1952 has been given a score out of 10 on what's called the AGPAR test. If you were born kicking and screaming, you probably would have scored 10. In 2008, when my son Tibor was born, things didn't start very well. He only scored 1 on the AGPAR test. So, in an emergency with doctors and nurses, I carried him up to the intensive care unit where he was attached to all kinds of tubes and wires. And for the next 3 weeks, his vital statistics were examined and monitored extremely closely. One of those measures was actually the oxygen in his blood, and if it started to dip, this sound, the pulse, would get both louder and accelerate, and then the nurses would come over and make sure everything was okay. The graph here represents the increasing and accelerating greenhouse gases in the atmosphere which humans have been driving forward. We've taken it from 2.1 watts per square meter to over 3.1 watts per square meter in the last 30 years. Now, that 2.1 to 3.1 watts per square meter doesn't sound like a lot, but it represents a total of 510 trillion watts over the whole atmosphere. And again, you may say, well, that's just a big number. Well, if you cash it out into an image that we can relate to, it's the equivalent of having 600,000 atomic bombs a day extra exploding above our heads. That's how much extra thermal energy we have pumped into the system. So when you look at that graph with those lines of 0.1 degree warming lined up, you can see that the pulse is getting more and more frequent. It's like an alarm signal which is getting louder and louder, warning us that we're heading into dangerous territory. Now, this might all sound a bit confusing. I mean, everybody's seen extra solar panels, climate change is in the news, there's been strikes recently, etc. And so you might think, well, where is all this extra greenhouse gas coming from? What's happened to this green transition? Well, the word transition is basically completely wrong. There's never been one. Transition is really a very unhelpful word. I can prove my point here. Just look at these two graphs from the International Energy Agency. The first graph from 1970, the total fossil fuel for all our energy needs is over 80%. And in the next graph, taken from 2019, it's also over 80%. So we have still a huge dependency on fossil fuel. Now the number to be really attentive to here is the number in the middle, the 254, because in 1970 we needed far less energy. Population increase, technology increase, and manufacturing increase, consumption increase on our material growth driven economy has pushed that number into the 600s. So first of all, we still have a very heavy fossil fuel based economy, and secondly, that economy has grown enormously. It's tripled in size. So even if we're doing green energy, it's not eating into, in any significant way, our greenhouse gas emissions, and that is why they continue to go up. Not only go up, but accelerate. So we seem to have an economy that is basically drilled into increasing greenhouse gases, even if it's not in our best interest. Now, before we get into the details of just how close we are to 1.5 and 2 degrees because of this acceleration, I think it's important to try and visualize what human society is doing. And we can do that with a roll of cheese. this section of the video, things have to be very precise. So the scientists who you can see listed now, these are all the world's climate experts, the highest ranking climate scientists that we have. This is our best knowledge and our best understanding of the carbon budget. Now, I'm only a philosophy teacher, and so I'm going to have to illustrate their words by using simple things like a plastic cup and a little mixing bowl from my kitchen. Now, let's start with this. This plastic cup represents the 42 gigatons of carbon which we put into the atmosphere every year as a human species. So we add 42 extra gigatons of carbon into the atmosphere. This represents how much carbon is left for 1.5 degrees of warming. So as soon as we fill this, we have locked in a 1.5 degree warmer world. So let's see how long our current level of emissions is going to last. So this is year number 1. This is year number 2. Another 42 gigatons, although we're actually accelerating, so it's probably going to be a little bit more than that. And finally, this is the 4th year, and you can see that the carbon budget is basically exhausted. There's just a little bit of room left, so that in about 4 or 5 years, depending on when you're watching this video, the carbon budget for 1.5 will have been exhausted. To be a little bit more precise, the carbon budget for 1.5 degrees is 183 gigatons, so 42 into 183. And of course it makes sense that the carbon budget for 2 degrees is much bigger, and I'm not going to perform this one because it would take too long, but basically it's a much bigger pot for 2 degrees warming. It's actually just under 1,000 gigatons. So in order for humanity to not go over 1.5 degrees warming, what we have to do is we have to reduce our emissions every year by, on average, 16%, starting from today. In 2008, Germany banned smoking in all restaurants. And I was living in Germany at the time. And before then, when you went into a restaurant, the waiter would, or waitress would, welcome you at the door and then ask you, would you like a smoking or a non-smoking table? Now, in reality, all that happened was that you walked towards a table, and if you said no smoking, they took away the ashtray. But you still had to eat your dinner in a restaurant full of smoke. Now, in a way, that's a little bit like how the atmosphere is, because all the greenhouse gases which we put up into the atmosphere immediately get spread about. And so any one country that's emitting a lot of greenhouse gases basically immediately shares it with everybody else, even if they don't want it. Now, if you want to imagine this a little bit more clearly, here is the United Kingdom. You can tell it's the United Kingdom because people are drinking tea and having a bit of a laugh, and well, there are some French tourists here as well. And I think my son has added Yoda on a skateboard. Now, if this is the UK in the 1850s at the start of the Industrial Revolution, then of course is going to be putting up into the atmosphere all sorts of CO2. Now imagine if at the beginning of the Industrial Revolution there was somehow some kind of glass bowl in the sky which trapped all the CO2 for British people to live with. Well, if that would have been the case, then today Great Britain would have a global warming of around 4 degrees C, hyperparexia from previous episodes. But luckily for English people, they've been able to spread their CO2 emissions across the world. And so everybody has had to live with Great British, well, not exactly great, but Great British CO2. So, in conclusion, we know very clearly what our vital statistics are. We know them for 1.5 degrees of warming, and we know them for 2 degrees of warming. These gigatons, defined by the laws of physics and chemistry, will determine what kind of future we're going to live in. But oddly, when policymakers or politicians, when the media, when they track climate change, they don't have these numbers central in their minds. Everything when we talk about climate change reductions has just got nothing to do with these boxes, with the science. That simply has to change. We have to put these vital statistics squarely in the media. However, there's another extra layer to this, because of course it's all very well knowing what the global budget is, but how do you divide that with the world's population? Now, the first principle, of course, is that it should be divided equally. Everybody has an equal right to the atmosphere. But as we've just seen, different nations and different people are using up that budget at different speeds. And in the next episode, we'll look at who is doing what and which nations have to travel at what speeds in order to stay within these budgets. And that is called the Cut X index, or Cut X percent.